Okay, hi. Thank you for coming. My name is Stanislav, so just for short it will stand, because we Russians, we have very long names sometimes. I'm a trainer, I'm an instructor in the training center of the Eltex, the Russian producer of network equipment. You all know us. I do assume so, as soon as you have come here. So today we'll be talking about our switching technologies and so, especially about the security functions, and to be precise about the three functions, which are the PortSecurity function, the LoopbackDetection function, and the StormControl function. All these functions and all these technologies are aimed at the securing of the endpoint ports at the access layer of the standard hierarchical model. I see that you are looking forward for the webinar, so we have just started. Thank you very much for coming. There are some 5 or 6 people already here. I do hope there will be more. 7, I'm sorry. Sorry so much. There are 7 of us. We'll be here around 1.5 hours. A little bit of theory, a little bit of commands, and then we will make a bit of demonstration for all the 3 functions. We have, like you can see here, yep. So somewhere here you have you see this Y corner, around 3 switches here today with us, and they will probably help to demonstrate all what they can in the respect of securing the ports. Okay, what have I done? Yep, nothing. So let's start. You are free, you are deeply and kindly encouraged to ask your questions in the chat. We have, so I will try to answer them as soon as I see them. Probably, maybe there will be some time before I see them, so I'm sorry. And also we have with us today the technical specialist Daria Shukina. She will be helping in moderating the session. Dasha, hello. Let's start. And the first thing we will be talking about today is the attacks we will be protecting our network from. So the first attack we will be talking about is the DHCP starvation attack. You all know what it is. For example, we can have some adversary, like we call them Alice. Yeah, it is. I don't know why though, but all the cybersecurity textbooks are full of Alices and Bobs. So we choose Alice here today. So for example, some adversary who wants to deprive us of the services of the DHCP server, they can perpetrate such an attack like link to our network, connect to our network, and then start sending random DHCP discover messages from, like you see here, from different MAC addresses, from random source MAC addresses. This is a very uncomplicated attack, but still it is very effective, as as you know that DHCP discover messages, they are propagated through the network, through all the L2 network and all the L3 network, whenever you have the DHCP helper address, or whenever you have the DHCP relay, DHCP relay function activated on your switches. Whenever you send the DHCP discover message, you can be sure that it will reach the DHCP server. What happens next? The DHCP server, the DHCP protocol is not really complicated. It is prone to the attacks. It is prone to very simple attacks, which is even more sad thing. But it is our responsibility to protect it. The DHCP protocol itself, if you have studied it, I have no doubt that you have done it. So the DHCP protocol has no means installed in it to protect. So it has no authentication, it has no authorization means, so it answers all the DHCP discover messages that the server receives. How it answers the DHCP discover message? It books the IP address from the DHCP pool and then waits for some, I don't know, 5, 10, 15 seconds awaiting the DHCP request from the client. Alice, it is not a secret, Alice doesn't want to get the IP address. She or he wants to deprive us of the DHCP server. Yep. So it sends a lot, really a lot of DHCP discover messages, and for each of this message, like here they are marked D1, D2, and so up to DN, the DHCP server books some IP address from the pool. What happens next? When we reach the end of the pool, so the DHCP server stops working. It doesn't issue the offer messages, and so we don't have any IP addresses issued by the DHCP server. The most what we can have from it is the so-called APPA, automatically provisioned IP address. This is the most that the endpoint can get. And this address also will not be recognizable. So yes, of course, it will be recognizable on the local network, but it won't be routed. So it will be useless for the corporate network. So how can we protect ourselves, and how can we protect the network from such a blatant and brute force attack? At this port, so like where you are here. On the ports that are looking to the clients, we can issue some commands to configure the function which is called the PortSecurity function. So we limit the number of MAC addresses that can be learned on the port, on particular interface, on particular switch port. And then when this limitation, when the traffic limits reaches the limitations, no more MAC addresses will be learned, and so no more frames with the unlearned MAC addresses will be passed through the switch. Thus, we can reach the following, we may still have a large number of frames sent by Alice to the direction of our DHCP server, but we can learn here just 5 or 6 or maybe 1 or maybe 2 MAC addresses. So we learn this one and we learn this one, and other frames, other packets will be just discarded on this port. What means discarded? It means that we don't pass them through, we don't switch them. And so here on the side of the DHCP server we have the same situation. We issue one IP address, then the second IP address, third, fourth, that's all. And then we will be waiting for some time until the addresses here on this port are aging. So we'll be waiting for some maybe 30 seconds or maybe for 1 minute. During this time, the DHCP server will make sure that no one is going to send the request message, to confirm the choice or this address for the endpoint, and thus this address will be returned to the pool, to our DHCP server. And so in this way we will avoid the DHCP starvation. So we will always have some addresses inside the pool. The same kind of attack is the MAC poisoning attack. It is like a side effect of the DHCP spoofing or DHCP starvation attack, and this is aimed at the switch mainly, not at the DHCP server, but the target is the switch, the access switch. It works almost the same. Alice, like an adversary, sends a lot of frames with the forged source MAC addresses. In this way, every MAC address is learned here on this access port, yeah, and it is learned on the port, and the special record is made in the MAC address table or CAM table. As you are probably aware, I think you know it very well, that MAC address table is finite. Yeah. On some switches it is 16,000 records, 16,000 rows. In some 32,000, in some 65,000 rows, but still it is finite. So it has its end. And the rate with which this table may be filled is much higher as the number of records it may bear. So if the rate of sending the forged MAC addresses, the forged frames with forged MAC addresses, is really high, for example, you can fill this MAC address table in some 5 or 10 or maybe 20 seconds. It is unacceptable for us, as after the final record is filled, when the MAC address table is fully completed, then what we have? We have a very big and expensive hub instead of the switch, instead of the clever and smart device. It will start to send the frames it receives through all the ports, and thus we'll have our network completely completely failing and not working at all. Very soon we'll have no network to work with. So what we're doing here. Also, our remedy in this issue is the PortSecurity function. We are limiting the number of MAC addresses that can be learned on one port at one time. Yeah. So it will maybe if it is like access port with, for example, some 2 devices installed there, we may limit the number of MAC addresses that will be learned on this port down to 2. We don't need more, really. Why 2? The IP phone with 1 MAC address, and then the PC connected through this IP phone. It will be the second MAC address, so that's all. We don't need more. And if someone wants to connect its computer or any other device to this socket, then they will have nothing, because all the frames, all the packets will be discarded. That is how it works. Then we may, for additional security, we may even we can even shut the port down, so that no communication will pass through this port. Also, we may shut down the port and then place it to some unexisting VLAN, like VLAN 4095, that is the largest number, and it can be assigned to any working port. So this is also one of the measures. So let's see how can we do it. In order to properly configure the port security function, we should configure 4 aspects of this, and 4 characteristics. The first, we should define the maximum possible number of the MAC addresses that will be learned on the port. Second point, we must define the way the MAC addresses will be learned on the port, or how they will be learned, and will they be learned at all. Next, we should define how the learned MAC address will be stored. Will they be stored permanently, or will they be deleted when we reload the device, reload the switch? And then the last one, we should define and we should configure how the port will behave when it receives the frame with the unlearned, so unknown to it, will be unlearned source MAC address. Yeah. So let's see how can we do it at the MES 2300 series. So the first, we should know, the port security function is configured at the port on the interface, so it will be configured in the interface configuration mode. So we choose the interface, and then we should first define the number of MAC addresses that will be learned on the interface. So it is the port security max, very simple command. Port security max, and then the number of the MAC addresses that will be learning. Then the learning mode, or the port security mode. There are 3 possible modes of how can we learn the MAC addresses at the interface. The first one is the max addresses. The max addresses mode means that you are, or the port is learning some MAC addresses. They can age, so after a certain time, they will be deleted from the MAC address table, and the new MAC address may be learned. Yeah. This mode is very it is very useful at the uplinks. Yeah, at the uplink ports, so that we know that we may receive some, I don't know, 500, 100, 200, 500 MAC addresses from the aggregation layer, for example. Or we may choose to configure this function at the aggregation layer, at the downlink port at the aggregation layer, and there it will also be the max addresses mode. Why we just limit the number of MAC addresses at the port, but we don't discard the traffic. We don't shut down the port, and we don't limit the MAC addresses themselves. We just limit the number of them at one the same time. So it is this mode is more useful at the uplink ports. Then the secure mode. When you configure the secure mode, all the MAC addresses that are now learned, being learned at the MAC address table, they are deleted, so the switch deletes them, and start to learn the new addresses. And then after they are learned, after we reach the number of MAC addresses specified at the port security max command, after that we close the registration. Okay, the booking is over. No more guests on this port. Yeah, and then we forbid the aging, and we forbid the relearning. So no more new addresses will be learned. So we limit the list of the MAC addresses. This is the essence of this secure mode. This mode is really useful at the access layer. When you have some 2 or 3 or maybe 5 devices on one port that you are using, for example, the most common combination is two MAC addresses. As I said, you've got the IP phone plugged in some port, then you have the computer, the desktop computer, plugged into this IP phone to save the port space, the switch port space. So that's all. You don't need more, really. The port learns these MAC addresses, and then that's all. The registration is over. The list is full. And then, if you have some devices connected to this port, then something will happen. And what will happen we'll define at the next slide. Next one is the lock mode. What the lock mode does, it saves the picture that you right now have. For example, you have all the devices connected to some room. Yeah. So you've got a port connected to some low level layer. For example, you've got a port at the aggregation layer connected to some access port, and you know that there are some, I don't know, 10, 12, 20 devices, 12, 20 MAC addresses learned on this port. And you know that these are the devices you need, no more. Then you make the lock function, the lock mode. When you've got the lock mode, the MAC addresses learned on the interface, learned on the port, they will be secured, they will be remembered almost forever, and then they will not change, they will not age, so they will not be deleted from the MAC address table, and they will also, and new addresses will not be learned. So you fix the list of what you have right now. Very useful thing, but sometimes the secure mode is more, like to say, flexible. Yeah? Then the secure mode has 2 modes of storing the learned MAC addresses. The first one is the permanent. The permanent MAC address, when learned, they are stored at the startup configuration, at the running configuration, and also at the startup configuration. And it lives with the device, with the switch forever, almost forever, until you change it. If you don't, that's fine. Yep, very good question from Yekaterina. The 2400 series does support the PortSecurity more, and we will also revise this function on this series at next slide, almost in 2 or 5 minutes. Yeah, and we'll also try to configure them at the demonstration stage of our webinar. Another mode is the delete and reset. So these addresses, the learned addresses, they will be stored at the memory, the RAM of the switch, and they will be lost when you reload the switch. Okay, so what will we do when we violate, when the adversary or when the packet is violating our rules? So what will the switch do with this packet? What will do with this frame? So there are 3 modes of operation at the 2300 series. The first is discard. The frame is just discarded. It is not passed through, it is not let to pass through, and it will discard it. This mode is switched on by default, so you may not configure it by hand, but no need to. No need to do that. It will be also working. Another one is discard shutdown mode. When this port receives some frame with unlearned source MAC address, it is discarding the frame and shutting down the port. Also, this event will be recorded. I mean, it will log it with the syslog. Another mode is the most secure one. We discard the packet, we discard the frame, then we shut the port down, and then we place the port into the VLAN 4095. So we place the port into the VLAN no one ever reach. Yeah, it doesn't participate in the switching. No one can assign the ports to this VLAN, so it is just a dead zone. It is completely dead zone. No one goes there, and so no traffic will go into this port. This is the most secure precaution that we can imagine. So, for example, if we want to limit the number of MAC addresses to 2, like as I said, is the usual setup with the access ports, then make the security mode like secure, so that the frames are learned automatically, and then port security discard mode, and then also the last but not least, the most important command here is the port security. This is the most important because this command will activate the port security function at the port, at the interface. Yeah. So don't forget. Without it, it will not be working. Okay. And the show port security status command will show you the actual status of the secured ports, whether the port is enabled or disabled, and which action mode is provided for this port. Yeah, this is the 2300 series. What about the 2400 series? Also the 1400 series, 2400 series, and 3700 series as well. As you know, the 3700 series is our industrial lineup with the our industrial switches. One of them is the IP30 standard, and one of them is IP57 standard, so it is a highly secured switch. What can we do here? The first, like with the 2300 series, we should limit the number of MAC addresses at the port. So we choose the port, the interface G01, and then we have the command switch port security, MAC limit, and the number. Yeah? So this is not just port security max, but MAC limit. Then we have 4 modes for the port security operation. Here we got max addresses, the same as 2300 series. Then we have explicitly two secure modes, a secure delete and reset and secure permanent. So we don't specify specifically how the addresses will be stored. These are just 2 operation modes. And the lock mode, the same logic as with the 2300 series. The first one, the max addresses, you just specify the number of the MAC addresses. They may age, they may be relearned. There's no problem with that. Then, a secure delete and reset and secure permanent, you delete addresses from the MAC address table, then learn them one by one until the MAC limit command, until the number of specified in the MAC limit command, and then the lock mode, you fix what you have right now at the MAC address table, and then learn no more, relearn no more, and age no more. Okay. So, and then the violation modes, there are 3 of them. The first one is protect, which is the default mode. You just discard the switch will just discard the unknown frames, the frames with the unknown MAC addresses. Then restrict. The switch will be discarding the unknown MAC addresses and make the syslog messages and the SNMP traps. And discard shutdown. This is the mode only for. Not only for, but it doesn't only discard the traffic, but also shuts the port down. The ports will be shut down. It will go into the air disabled state. As you know, we have three down states: the NC not connected, then air disabled when it is shut down by the error, and then not the air disabled, but let me say administratively down when it is shut down by the administrator. So here the port will be placed into the air disabled state. So and the example for this will be like that. So we also should learn up to 2 MAC addresses, then permanently learn the MAC address, and then shut down the port when it is when some unknown frame comes in. So switch port security MAC limit 2, then port security more security permanent, and then port security violation restrict. Without shutting down the port. Okay, we don't want to shut the port down. And then the last command switch the function on the security port security enable. Yeah. And the special command, the special show command, show port interface gigabit 05. It will show the current state, security state of the port, which is right now it is disabled. Yeah, the MAC learning is disabled because we chose the secure mode, and then the violation type restrict. So it will not be shut down, but it will just be switched on and will pass the traffic when we have the legitimate traffic. Yeah. Yes, hi to everyone who have come who were coming during our session. Let me see how many of us there are here. 16 people, terrific number, like it. So, let's continue then with other attacks and with other function of ours. The second function that we will revise here, what we will consider during our webinar, is the loopback detection function. The loops are something to be really avoided, but they keep erasing, they keep happening, like other unpleasant things, but the loops, they keep happening. How can this happen? This picture that you are seeing right now, we have the access switch, then the structural cable system that the switch is connected to, and these are the sockets at the walls in some working rooms and some open space rooms and so on. That if you have been working as a system administrator or in IT, you know that the users are sometimes, to say the least, excessively inquisitive. Yeah, so they are excessively interested in what will happen if we plug the same patch cord into 2 different sockets. Yeah, sometimes they like to experiment. The loop will happen. It will lead to some unnecessary consequences in our cases, and the loop will lead to overloading of the CPU. It will lead to overload of the ASICs that are passing the traffic from the access ports and so on and so forth. So we should avoid the loops as far as we can. You may ask me, Stanislav, but we have the spanning tree protocol for this purpose. Yes, we do, but sometimes we should avoid the spanning tree as well. Why? This happens mostly when this access switch is not the access switch of some corporation, but the access switch of some internet service provider. And imagine that here we have not the corporate network, but here we have some doors, yeah, in the apartment blocks and so on. So we have some door here, and then this is our port which is under our control if we are the internet service provider. But what is happening right here, we don't know, and we have no right to go there and to check. So if we switch on the if we deploy the spanning tree protocol on such ports, on such access ports, then we'll have problems with the user may may arrange some loop inside the building, inside their apartment, inside their flat. So we cannot actively participate in this process, but we will see consequences. And if the loop is formed there, then our spanning tree protocol may block the port. And then they will not have the internet connectivity, and this will be a problem for our support service, for us, for our contractual obligations, and so on. So we should avoid the spanning tree protocol sometimes. But if we switch the spanning tree protocol off on the switch, what will happen? Then we will have the loop. And in this situation, the loopback detection function is very helpful for us. What it does, the loopback detection function sends, so if it is activated on the some switch port, it sends the so-called loopback detection packets, so loopback detection PDUs, with certain destination MAC addresses. It can be the broadcast MAC address, or it will be multicast MAC address, or it will be MAC address of the switch itself, or of the interface itself. Then we know that we have forged this packet, we are sending it, yeah, and if we receive this packet on our port, if it comes back, we know that there is a loop somewhere. It may be the two ends of the same patch cord plugged into the ports of our switch. It may be that someone out there made the loop, and so our packet went there and now is coming back. But they know that on this interface there is a loop, and this interface should be suspended. Yeah. What I mean by the suspended, it means that it will go down to the disabled state, and it won't be working. It will not be passing the traffic. Very, very, very simple mechanism. It is very, but a very useful tool. Like here, what we can do. By default, the loopback detection packets are sent with the interval of 30 seconds. Every 30 seconds, the switch is sending these loopback detection PDUs. However, you may adjust this interval from in the range from 1 second to 60 seconds. Yeah? The less the interval, the more the packets. This is the downside of this function. But the less the interval, the faster we know that there is a loop. And this is the upside of the situation. Provided we have a decent bandwidth on all the switches of ours, the upside is more than the downside here. So, if we send this packet and it comes back, and we understand that the destination MAC, the source MAC of this package, here it goes, it corresponds with our MAC address. They are the same, in fact. Then we know that somewhere is a loop. And if there is a loop, we are suspending the port. Like here it is marked with the red. So it means it doesn't work. Yeah. We are not interested whether this loop is made like here or it is made in somewhere in other network, but there is a threat for us. We got a threat of the storm, we got a threat of the circling traffic, so we are making this, so that is why we activate the loopback detection function at our switches. There are 4 options for the destination MAC addresses. One of them is the O1s, which is the broadcast MAC. Another one is the special multicast address, the CF and all zeros. Then it can be the base MAC address, I mean the MAC address of the switch, of the whole switch, and then it may be the MAC address of the particular interface. It can also be there. Yeah. So anytime we receive these addresses with our MAC address, with the MAC address of the sender, then we know there is a loop somewhere out there. Okay, how can we configure the loopback detection function? In fact, it is very easy. The syntax is the same for the 2300 and for 2400 models. Yeah, it is a rare occasion where when they are the same, so it's okay. Then we should make 2 things. The first, we should enable the loopback detection function globally. Yeah, so in the global configuration mode. The loopback detection enable a very simple command. Then also globally we may adjust the loopback detection interval from 1 to 60 seconds. We may also omit this step, as we will always have the 30 seconds interval configured by default. Then we should go to a particular interface and then enable the loopback detection there. Just loopback detection enable. No more commands is available there. So and when you enable the loopback detection on the interface or at the interface, correct me if I use the wrong proposition in English. Then after the enabling on the interface, the switch starting to start sending those loopback detection PDUs from this interface. Yeah. When you receive this when you receive the packet from out there indicating there is a loop, so you've got a message, the syslog message, that port number this and this is suspended by loopback detection. Yeah. When it is suspended, and if it is suspended, it will be marked as the R disabled. And when you want to switch it back to unshut it, so to bring it to life, you should do 2 things. If it is R disabled, then you should first shut the port down. First you make the shutdown, and then the no shutdown command. You issue 2 commands. If you want just to issue the no shutdown command, it will not work. It will not be working. So if the port is in R disabled state, first shut it down, then unshut it down. Yeah. So this is all about the loopback detection function. And the last one that we will consider today, you'll probably be getting tired from just a theoretical part, but I'm promising that very soon we'll start our practical part and start our demonstration. This StormControl function. Like you see in the picture, I imagine that we have some magnifying glass directed to some UTP cable. If we had such magnifying glass, we would see that there are some packets, there are some PDUs going to and fro here and there from the distribution switch to the access switch, or from the access switch to the distribution switch. They use various forwarding methods. They can be broadcasts packets, which are marked in red here. They may be the multicast packets that are marked in blue, and then they may be unicast packets, unicast frames. These are usual things. No one is paying attention to that until some form of casting is starting to prevail. For example, there may be a picture when all the bandwidth of the channel, all the bandwidth of the link is occupied by the broadcast packets. This is really a problem, as no other bandwidth is left. So we've got the link overloaded, then the port of the destinations, not destination, but the port of the distribution switch will also be overloaded here. And we also understand that as we have the broadcast traffic here, it will also be broadcasted from all the other ports of the distribution switch in one the same VLAN. So we've got a problem here. And all our network also may be overloaded with this kind of traffic. So what can we do to avoid this situation? A rather simple measure. We are limiting the traffic. We are limiting the number of packets, or we are limiting the kind of packets that may pass through this port, or pass through this interface. For example, it may be here or here. Here. So we will go to this interface, and then the limit of the number of broadcast traffic maybe to this. Yeah. Maybe to the percentage of the bandwidth it may occupy, or to the number of packets, or to the number of to the volume of traffic, which is measured in the kilobits per second, thousands of bits per second. We may limit the traffic and then say to the switch, okay, if this kind of traffic is accessing or is exceeding the prescribed limit, if it exceeds the limit, then please do us a favor, shut the port down, please. Of course, the port is not shut down, it just goes to the disabled state, and then we may also bring it to life later, but still, it is a very effective measure when we have a storm. The most common situation when we have a storm is we have a storm at the distribution part here when there is a loop at the access layer. So we've got the broadcast traffic here looping, yeah. So it is multiplying, and also the packets coming, for example, from this port, they are coming here, and from this port they also are propagated on all the other ports. This is the essence of how the switch is working. And then we have the stream of the broadcast packets. It is not necessarily broadcast packets. There can be the multicast packets as well, or the unknown unicast packets as well. So no problem with that. We have many sources of problems, potential sources of problems. And then all the stream is going right here. And in this case, the port is becoming overloaded, and what is more important, our CPU can also become overloaded, and so we may lose the connectivity to the device, and we may lose the connectivity to all the other network. So to avoid this, we should just shut the port down here when we have some excessive stream of packets. Yeah. So let's have a look of how can we do it. Also, 3 points, 3 things that we should consider when configuring the StormControl function. First, is the I mean the StormControl actions, or what can we do with the traffic stream when it exceeds the prescribed limit. The first is the trap. So we keep the traffic going, we don't shut the port down, but we send the SNMP trap about the event. So we are notifying the administrator and with the logging, of course with the syslog, we logging the event, but we also notify the administrator somewhere out there via SNMP that, okay guys, we have a problem. Houston, we have a problem. Then we may shut down the device. We may shut down the port. Just simple as that. At the event will be logged, of course, but the port will be shut down. No more traffic will be passed. This is what is recommended to do with the broadcast and with the unknown unicast traffic. Yeah, this is really dangerous to have them, to let them on the network when they exceed the limits. And then the trap and shutdown, which means we shut the port down, but necessarily issue the trap message. Yeah, this is the most informative yet very secure option of this. Okay, 2300, 3300, 3500, and 5324 series, our most advanced series of switches, I mean in the respect of access switches. So just one command for all of this. The StormControl, then we choose the kind of traffic, the type of traffic, the broadcast, multicast, or unicast. Then the unit of measurement, kilobits per second, packets per second, or the level. When we are talking about the level in the in connection with the 2300 series, it means the percentage of the bandwidth that we allow the traffic to occupy. And then we are taking the necessary action: trap or shutdown, or trap and shutdown. Yeah. Then the configuration example is like that. So StormControl, broadcast level 5, trap shutdown. What it means? It means that we are allowing only the broadcast traffic to occupy only 5% of the actual bandwidth on a link. Yeah, and then we are issuing the trap, the SNMP trap message, and then we are shutting the port down. Yeah. If we use the StormControl multicast kilobit per second 20, 480, and so on and so forth, and trap, it means that for multicast traffic, when it reaches the 20 megabits per second, yeah, we are just issuing the trap message. We're issuing the trap message, SNMP trap, and then that's all. That's all we want. We don't want to shut the port down. We don't want to interrupt the multicast traffic. We're just letting the administrator know that something is going on the network which is really not really desirable, not so desirable. Then another one, which is StormControl, unicast, and so on. Unicast traffic which of course it is not all the unicast, it is unknown unicast traffic. What is the unknown unicast traffic? It is a packet, unicast packet, to the destination address that our switch doesn't yet know. So it has to propagate it through all the ports. So it is a unicast traffic that behave like multicast or like broadcast traffic. Yeah, and it can also make the loop, and it also make us give us a terrible headache. So packet per second. When we are talking about the packets, we consider the Ethernet packets or Ethernet packets or L2 packets, which is the preamble, the Ethernet packet, and the inter-packet gap after the packet, inter-packet gap after the actual frame, after the frame sequence. Yeah. So this is the packet. This is the extended frame, like we will also say. This is extended frame. Usually, it is twice the size of the actual frame. So, like you know, so if we have more than 5,000 packets per second, then we shut down the interface. Yeah. May I ask you the question? May I ask you the question? So please answer at the answer in the chat. Which of the traffic types, the storm control of which traffic types should be configured on the port to make the maximum security, to reach the maximum security? Which one would you choose? The broadcast traffic, the multicast traffic, or unicast traffic for the storm control configuration? Okay, you don't ask me questions, so I'm asking you. Okay, this is a tricky question, so I'll answer myself. All three. You should configure all three for the maximum security, because you don't know which storm type will arise next. You really don't know. And each of these functions, so if you are looking for the broadcast packets, it will not react to the multicast packets. Yeah, so multicast storm may arise. If you're looking for broadcast and multicast packets, then unicast packets may take their way through. So all three of the kinds of the multicast or the storm control packets must be enabled. Okay, the 1400 series, 2400 series, we have slightly different model of configuration. So we just so we have two commands. The first of them sets the limits for the traffic, for the broadcast, multicast, and so on. And the second command chooses the action for the traffic. Yeah. So if you don't want to make any action, if you don't want to switch the port, so just don't choose the action command, and then there will be no problem. You will be just notified, not notified properly, but you will be so the yes, maybe notified while the syslog message is not quite a notification, just a logging. So you will see the event you will see the broadcast storm event or multicast storm event within the log, but you will not be properly notified within SNMP. So the first command, the storm control kind of traffic, the traffic type. Here the word level doesn't mean that it is the percentage of the actual bandwidth, no way, but just word level, which means the further indication of kilobit per second, so packet per second, and then the value of this unit of measurement. Then storm control, broadcast, multicast, or unknown unicast. Here it is. This series of switches, it is named the DLF. Then you choose the action, trap and shutdown, or just shutdown. Yeah. If you choose trap or trap and shutdown, then you will get the SNMP notification. If you choose the shutdown, then you will have no notification via SNMP. What can be done here? So broadcast level, packets per second 1000. If you get 1000 packets per second, then the action will be shut down to avoid the further problems. Then for multicast level, you will have 40 megabits per second, and then just trap. So the trap will be notification there. And then for unknown unicast traffic, if the unknown unicast traffic exceeds the 20 megabits per second, then you will have the trap and shutdown. So the port will be shut down, and you will have also the notification about this. Okay, so we have here the slide about the questions and answers, but first I would like to make some configurations, yeah, if you don't mind. Yeah. So we'll have port security, yeah. Then we'll configure. Yeah, this is the practical part. If you have questions regarding the theoretical part, please ask in the chat. I'm looking at this, so I will be trying to react, and also Daria will react as well. But still, please let me know if the size of the letters is okay for you, if you see them. Yeah. Please let me know in the chat. So let me see the what to do. Yeah, the port security issue. The first one will be the port. Yeah, here. Here we go. We'll be configuring the port security at the 2400 series. No, here admin. Never do it in production, but still. Okay. We're going to the configuration mode, global configuration mode, and then we will choose some interface. In our case, it is the interface number 3. Interface G03. Here we go. Yeah, you can see it. Thank you, Daria. Okay, so port security. What we are doing here: switch port security. First, the MAC limit. MAC limit will be 1. Yeah, we're going extreme. Just to this will going to be the single device. So just for the demonstration purposes, you know. In fact, in real life there will be more. So MAC limit 1. Switch port security mode. Let it be like secure permanent, yeah. And also switch port security violation. It's gonna be discard shutdown. Yeah, we are going all in. in this respect. Yeah. So let's try to find something. So now I will plug this port into one switch. Into the first switch, we'll learn the MAC address, and we will see that we will make sure that we have learned it. And then I will plug this port into another switch that we have here, and it should go down. Yeah. So violation discard shutdown. Yeah. First one. Let's go. Boom. We have learned something. Then do show MAC address table. So we have learned something. Yeah. And on the G13, we have learned 2 MAC addresses. Sorry. I'm sorry. I'm so sorry. I forgot one thing. What have I forgotten? I've forgotten to activate the port security feature. Switch port, port security, port security, enable. Here that we are now starting to understand everything in this life. So, let's go. Yep. Okay. We have learned 2 addresses because on this port we have learned the why. We have learned 2 addresses. Why have we done so? The first MAC address was the one of the switch itself, and another one of the interface. So we have learned 2. Do show MAC address table. Yeah. So here we have learned this one. Yep. And it was learned securely. Yeah. On the port G0.3. So we got the result. And then do show port interface G13. Yep. So here we go, MAC learning enable, although it is disabled right now, but generally it is enabled, and the security violation type, discard shutdown. That's what we have in practice. And also, if we want to do show interface status, here we go, port number 3, it is down R. It is R disabled. Yeah. One more thing that we may also do is the automation of the recovery. Yeah. Now that we have some ports in the disable mode, we may also configure the disable recovery function. It automates the recovery of the many ports. Like how we can do it. The R disable recovery, yeah, calls port security. So it means that the ports that are put in the disable state by the port security function, no other, but by the port security function, they will be revived, reactivated after some interval. Like let us, usually it is 30 seconds, or I think usually it is 60 seconds, but we can make the interval less. But the least possible interval is 30 seconds. So let's try it. Disable recovery interval. How many? Yeah, 30 seconds. So after 30 seconds, we will see that the port will be revived, but still it will go down. As the spanning tree is activated at the 2300 series. Yeah. Let's wait a bit. Oh, let's not. Oh yeah, here we go. The report is recovered by PortSecurity. And then, so when it launches another, oh yeah, here we go. It is suspended one more time. Yeah. We have a unique situation right here because we are working with the switch. If I had an endpoint here, so there will not be, there wouldn't be any problem with that. So we would use one MAC address. No more problems with that. Yeah. So that's okay. Okay, like we also do like this so that this port is not bothering us in the future. So interface G03, no port security, no, I'm sorry, switch port security enable, and then there will be no problem. Okay. So we'll come back to our switch a bit later. Yeah. Okay, let's be there. But right now we need to arrange a loop out here. Yeah. So what we have here at the 2300 series. Yeah. So we'll make a loop here and then we'll try to avoid it. Yeah. What we have here do show interface status. You see that we have some ports. It's upstate, and then we definitely have a loop between the ports 2 and 5. Yeah. No, 2 and yeah, it is a loop between the ports 2 and 4. How can we prove it? Yeah. Do show LDP neighbors. Yeah. We see one the same device. Yeah. At the ports 2 and 4. 2 and 4. Yeah. One the same. At one the same switch. So yeah, it is. So we definitely have a loop, but we don't have any traffic fluctuation. We don't have any max flapping. We don't have any problems. And also show CPU utilization. If we see the CPU utilization, it is quite normal. Nothing is going on. Yeah. So we don't have any problem. But we still have a loop. Why? The spanning tree. The spanning tree is activated at the switch. Let's make some changes in this situation. No spanning tree. Then we're going to have problems immediately. Yeah, we do have it. I see. Yeah, I see the flapping. And if we see, if we have a look at show CPU utilization, it is rising. It is rising. It is already 36%. And if we see the do show interfaces utilization, interface 2, for example, utilization. Oh, sorry, interface utilization here. Yep. We see that we have the rising number of frames, which is going up and up and up and up. So we have problems. Really we do. How can we get rid of them? First, let's activate, I'm sorry for my Russian accent, but let's activate the loopback detection function globally. Loopback detection, enable. Yep. So, and then let's make the loopback detection interval a bit less. So now it is 30 seconds. It is too long to wait. So we have the MAC flapping, yep. Loopback detection interval. Let's make it 5 seconds. Yeah. Just to be on the safe side. Then let's go to the range of the ports from, I think, from 2 to 4. Yeah. Interface range 0, 2 to 4. And then activate loopback detection here. loopback detection enabled. 1, 2, 3, 4, 5, 6. Yep. The port is suspended by the loopback detection, one of them. And we've got 2 ports going down because they are linked. And when one is going down, another will go down as well. But there is difference. Those show interface status. The port number 2, the port number 4, is disabled by the loopback detection. Yeah, it is disabled. But port number 2 is just NC, so it is not connected. It doesn't see the port on the other side of the patch cord. Yeah. So we've got 2 ports going down, but we have gotten rid of the loop. So there is no loop. Yeah, there is no loop. Let's deactivate the loopback detection. Why I do this? We are doing this because we need a storm on the 2400 series to see the storm is coming. Yeah. So how can we do it? No loopback detection enable. Yeah. So we have globally disabled the loopback detection, and also we should recover the ports. Interface GI 04, shutdown, no shutdown. Okay. So it is going up. If it has gone up, 1, 2, 3, 4, 5. No loopback detection activated, so it will be freely sending the storm to the 2400 series. Let's see them. Okay. And then we have a real problem here. Yeah, we have problems here. Because the storm, it is a multicast storm, because the switch is sending BPDUs in here through loop. So in fact, we have sent the BPDU to this switch without the spanning tree. It has looped from the port 2 to port 4, and then it is now coming back to us. So we've got problems here. Let's deactivate the port and then make the connection, because yes, interface G03 shut down, so that we don't have the headache and we don't have all the messages coming to our console port, and don't have trouble with our eyes. Now we are configuring this storm control function. Yeah, here very peacefully, very calmly. The storm is going on somewhere there, and we don't feel it here, but still. Yeah. So storm. Yeah. Let's see. But first, before they see how the storm control function works, let's see the rising characteristic of the utilization of the port and of the CPU as well. Yeah. So I will unshut down the port. Okay, here we go. So do show interface utilization G03. And we see immediately that the number of frames that the port receives is rising. And it's rising with the time. Yeah. If I consider, so it is also around 1 million. And if we see the do show CPU utilization, do show CPU utilization. Oh no, it's not working. It's not even working. So we're shutting down the ports. I'm sorry. And so we will be protecting us from the storm. Yeah, storm control. We will consider all the 3 storms so that we see which one will be working. Storm control broadcast. Level PPS packet per second, let be 1000. Okay, and StormControl broadcast action will be trap, action will be trap and shut down. Then this is the broadcast. Let's attend to multicast traffic. So StormControl multicast level. Packets per second, let it be the 5,000. StormControl multicast still level, no, 5,000 is too much, like we did 2,000. StormControl multicast level, action, trap. Let's try the trap. And then StormControl DLF level, kilobits per second, let it be 2040 480. StormControl DLF action, shut down. Okay, that's all. That's all. No shut. The link goes up, and it is immediately suspended by the StormControl. It is immediately suspended by broadcast storm event detected. Yes, it was a broadcast storm, and it was immediately detected and immediately suspended by the StormControl. Yeah. So it is, as you see, so let's see the utilization interface. So show interface G03 utilization. Show interface utilization G03. Do show. Sorry. Face G03 utilization. Now. Sorry. Yeah, here we go. Almost nothing. Almost nothing. Calm and flat. Just a sea breeze coming from the sea. Everything is okay and everything is going calm. So that is a very useful function. I think they all three are really useful so that they can protect from the occasional problems that you might have, especially at the access layer, and so I think that I do hope that it will be useful for you when you consider your network and when you administer your network with our equipment. Now, I'll be more than happy to try and answer your questions. Please go ahead. So, if nothing is coming, thank you very much for your time. Thank you very much for attending. I do hope it is not our last meeting. Yeah. So we'll be impatiently waiting for you to our other webinars. We got a lot of interesting topics. We got a lot of interesting people. To be honest, my topic was one of the simplest ones. So I do hope it was interesting And I do encourage you to join me in thanking our marketing team, in thanking Daria for your readiness to cooperate and answer your questions as a moderator. Yep. So thank you very much. Thank you for coming. I will be looking forward to meeting you in our session and maybe sometimes in real life. Yep. Why not? Why not? So if you happen to pass through Siberia in Novosibirsk, so welcome. Thank you very much and goodbye.